Tonight, we're going to explore the largest galaxy we've ever found. This is not something you need to understand all at once. The scale of the cosmos is not a riddle to be solved, but a landscape to be viewed from a distance. You don't need to remember every number, every light year, or every scientific designation. You can simply listen and allow your thoughts to drift as we move slowly outward, away from the familiar and into the vast, silent stretches of the deep universe. To begin, let's start with something familiar. Let's start with the ground beneath you and the quiet air of the room where you currently rest. The world feels solid and manageable here, but as we settle into this space, we will begin to expand our perspective, moving from the things we can touch to the things that exist on scales so large they challenge our very definition of a place. There is a quiet rhythm to the universe. It moves slowly, without urgency, and for the next few hours, we will follow that rhythm. There is no rush to reach the end. The stars are patient, and so are we. Tonight, we are going to explore the largest galaxy we've ever found. This is not something you need to understand all at once. The scale of the cosmos is not a riddle to be solved, but a landscape to be viewed from a distance, where the jagged edges of reality are softened by the immense depth of time. You don't need to remember every scientific designation or every light year. You can simply listen and allow your thoughts to drift as we move slowly outward, away from the familiar and into the silent stretches of the deep universe. As you breathe, imagine the air around you as the very thin, very delicate skin of a planet drifting through a cold and silent sea. We often think of our world as the center of everything, a sturdy stage upon which our lives unfold. But tonight, we will gently lift our gaze. We will look past the ceiling, past the atmosphere, and past the familiar glow of the moon. We are venturing toward a structure so vast that it makes our entire solar system look like a single, microscopic speck of dust caught in a beam of sunlight. This is a journey of expansion, a gradual letting go of the small measurements we use to organize our days. In the chapters to come, we will encounter EC 1101, a titan of the Abell cluster. It is a place where light itself becomes weary from the distance it must travel. But before we arrive there, we must first learn to be comfortable with the silence. We must accept that in the grand architecture of the cosmos, speed is irrelevant and distance is a form of meditation. There is a deep, underlying peace in realizing that the universe does not demand our comprehension to continue its slow, magnificent work. As the room grows quieter, let your mind become as vast and as still as the space between the stars. We are moving now, away from the solid ground, stepping into the gentle, unending current of the cosmic stream. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about the largest galaxy in the universe, we often imagine it in human terms. We try to use distances we can walk or time we can measure in years. But human scales are like a small candle held up against a vast, dark ocean. To understand where we are going, consider a simple walk. If you were to walk at a steady pace, without stopping for sleep or food, it would take you about a year to walk the circumference of the Earth. That feels like a significant distance, a long, weary journey across continents and seas. Now, imagine that journey scaled up. If you were to drive a car at highway speeds toward the sun, it would take you about 193 years to arrive. Multiple generations of your family would be born and grow old within that car before the dashboard clock reached its destination. That is just our local neighborhood. When we talk about galaxies like IC 1000, 101, our human measurements, miles, kilometers, even the distance to the sun, become almost humorous in their inadequacy. They are like trying to measure the volume of the Pacific Ocean using a single teaspoon. This comparison isn't perfect, but it gives us a calm place to begin. It allows us to recognize that our smallness isn't a limitation, but a starting point for wonder. To understand the giant, we must first understand the grain of sand. We must look at the tools we carry in our pockets, the rulers, the clocks, and the maps, and realize that they were designed for a much smaller house. Consider the simple act of walking. For a human, a walk across a meadow is a pleasant way to spend an afternoon. A walk across a continent is a feat of legendary proportions, something that would take months of steady, rhythmic effort. If you were to set out on foot to circle the entire Earth, you would be walking for nearly a year without rest. Your shoes would wear thin, the seasons would change around you, and by the time you return to your starting point, the world would have aged. To us, the Earth is the definition of vast. It is the horizon that never ends, the solid ground that holds everything we have ever known. But if we step just 1 inch away from the Earth's surface, our perspective begins to stretch. Imagine a car traveling at a steady speed on a long, straight highway. If that highway led to the moon, you would be driving for about 6 months. It would be a quiet trip, a long period of looking out the window at the approaching white sphere. But if you turned that car toward the sun, the journey would change. To reach the sun at highway speeds, you would need to drive for 193 years. You would not finish the trip. Your children would not finish the trip. It would be your great-great-grandchildren who finally felt the warmth of our star growing closer. This is the scale of our local neighborhood, a distance that already exceeds the span of a single human life. Yet, even this 193-year journey is a microscopic flicker to a galaxy like IC 1000, 101. The distance between the Earth and the Sun is practically zero. It is a rounding error. It is the thickness of a single coat of paint on a skyscraper. When astronomers look out into the deep field, they have to stop using miles and kilometers entirely. These numbers become too heavy to carry. They have too many zeros. They clutter the mind and lose their meaning. Instead, they use light. Light is the fastest traveler in the universe, moving at 186,000 miles every single second. In the time it takes you to blink, light has already circled the Earth 7 times. It is a speed so fundamental that it defines the rhythm of existence. To light, the trip to the moon takes a little over 1 second. The trip to the sun takes 8 minutes. If the sun were to suddenly go dark, we would continue to live in its warmth and light for 8 minutes, unaware that the source had vanished. We are always living in the recent past. But even light, as fast as it is, begins to feel slow when we look toward the larger structures of the universe. To cross our own galaxy, the Milky Way, light must travel for 100,000 years. This means when we look at the stars on the far side of our home, we are seeing them as they were when early humans were first beginning to use stone tools. We are looking at a ghost of a time we cannot remember. Now, hold that 100,000-year journey in your mind. It is a vast stretch of time, spanning the entire history of our species. And then, consider IC 1101. This galaxy is so large that light requires 6 million years to cross it. 6 million years. When a photon of light begins its journey at one edge of IC 1101, our ancestors on Earth were not yet human. They were distant relatives wandering the forests of Africa. By the time that photon reaches the other side of the galaxy, civilizations have risen, built pyramids, invented electricity, launched satellites, and perhaps faded away. The galaxy is so wide that it contains the entirety of human evolution within a single crossing of a light beam. This scale is not meant to be frightening. It is meant to be a release. When we realize that a single object can be so large that it dwarfs our entire history, our daily anxieties begin to lose their weight. The deadlines, the small worries, the brief tensions of a Tuesday afternoon, they do not exist on the scale of 6 million light years. They are absorbed by the golden glow of 1 trillion stars. In the Abell cluster, where IC 1101 resides, time moves with a different gravity. It is a slow, heavy time that does not care for the ticking of a wristwatch. Think of a single star in our sky. It is a massive, burning ball of plasma, millions of times larger than the Earth. Now imagine 100 billion of those stars. That is our Milky Way. Now, try to imagine 100 trillion stars. That is the population of IC 1101. If every star in that galaxy were a single grain of sand, you would have enough sand to fill a beach that stretches across the entire planet. Not just one coastline, but every continent, every desert, every mountain, covered in a thick layer of stars. And each of those stars is a sun, potentially holding planets, moons, and rings of ice. We often imagine galaxies as flat spirals, like the ones we see in textbooks. But IC 1101 is an elliptical galaxy. It is a great, swollen orb of ancient light. It doesn't have the youthful, frantic energy of a spiral galaxy with its new stars and bright blue gas. It is a collection of old souls, red and yellow stars that have been burning for 10 billion years. It is a retirement home for suns. It is calm. It is stable. It has reached a size where it no longer needs to rush. It simply sits at the center of its cluster, a gravitational anchor for thousands of other, smaller galaxies that orbit it like moths around a campfire. To understand the mass of such a place, we have to think about gravity. Gravity is the quietest force, but it is the most persistent. It is the shepherd of the stars. In a galaxy as large as IC 1101, gravity is so strong that it bends the path of light itself. It pulls on the very fabric of space, creating a well so deep that anything nearby is eventually drawn in. Over billions of years, IC 1101 grew to its current size by eating other galaxies. It is a slow-motion consumer. It doesn't hunt, it simply waits. Smaller galaxies, distracted by their own internal dances, eventually drift too close. They are stretched, pulled apart, and woven into the golden fabric of the giant. This is not a violent act in the cosmic sense. It is a merger. It is a way for the universe to organize itself into larger and larger patterns. If you were standing on a planet in the middle of IC 1101, the night sky would not look like ours. Here on Earth, we see a few thousand stars and the dark, dusty band of the Milky Way. In the heart of the giant, the sky would be a solid, glowing canopy. There would be no true darkness. The density of stars is so high that the night would be as bright as a permanent twilight. You would be surrounded by the light of 1 trillion suns, a warm, amber glow that never fades. It would be a world without shadows, a place of infinite, soft illumination. But from our distance, IC 1101 is just a smudge of light in a telescope. It is a quiet reminder that the universe is capable of making things we cannot fully name. We call it a galaxy, but the word feels too small. It is a continent of light. It is a reservoir of history. It is a place where the laws of physics are the same as they are here, but the results are vastly more ambitious. As you lie here, safe and still, let the image of this golden giant rest in your mind. You are not required to measure it. You are not required to cross it. You are simply invited to acknowledge that it exists. Like a mountain in the distance or the deep currents of the sea, it is there, whether we watch it or not. It moves with a slow, heavy grace, orbiting a center we can only guess at, participating in a cosmic cycle that spans billions of years. The teaspoon and the ocean, the grain of sand and the beach, the human and the galaxy, we are the small observers of the very large, and there is a profound peace in being small. It means we don't have to carry the weight of the universe. We don't have to manage the orbits of 1 trillion stars. We can simply drift. We can allow the scale of the giant to remind us that the universe is vast enough to hold all of our mysteries, all of our questions, and all of our silence. Scientists understand IC 1101 by watching the way the galaxies around it move. They see the dark matter that must be there to provide the extra gravity needed to hold such a massive structure together. They see the intracluster light, a faint, ghostly glow between the galaxies where stars have been stripped away from their homes and now wander the void alone. It is a complex, beautiful system, but at its heart, it is simple. It is a collection of light, held together by the same forces that keep your feet on the floor. Over the next few hours, we will move closer to this giant. We will look at its stars, its history, and its eventual fate. But for now, stay here in the human scale. Stay with the breath. Stay with the quiet. The giant is far away, and it is moving slowly. It is patient. It has been waiting for 6 billion years for its light to reach you. It can wait a little longer while you rest. Everything is in its place. The Earth is beneath you, the moon is above you, and the largest galaxy we've ever found is out there, glowing softly in the deep, a golden anchor in the dark. It is not a place of chaos, but a place of incredible, ancient order. And as we begin our slow expansion outward, we do so with the knowledge that we are safe in our smallness, drifting in a universe that is far too big for anything but peace. To find comfort in this vastness, we must return to the simple things we understand: the weight of a hand, the length of a step, and the steady passage of the seasons. These are our anchors. Without them, the scale of IC 1101 would be too heavy to hold. But with them, it becomes a beautiful, distant horizon. Consider for a moment the concept of a neighborhood. In our daily lives, A neighborhood is a collection of streets, a few houses, and perhaps a park where the trees change color in the autumn. It is a place where you know the distance from your front door to the corner store. If you were to walk that distance, it might take you 5 minutes. In those 5 minutes, your heart beats a few hundred times, and the world remains exactly as you expect it to be. This is the scale at which we are designed to function. Our eyes are tuned to see the texture of a leaf or the expression on a friend's face. We are creatures of the local and the immediate. Now, imagine if we were to expand that neighborhood. If we look up at the moon, we are looking at an object that is roughly 238,000 miles away. To a human, that number is abstract. It is just a 2 and a 3 and an 8. But if you were to attempt to walk to the moon, it would take you nearly 9 years of continuous, non-stop effort. You would walk through every season 9 times. You would watch the constellations shift slightly in the sky. By the time you arrived, the world you left behind would have moved on. And yet, on the cosmic map, the moon is so close it is practically touching us. It is the very first step on a staircase that has billions of flights. Over the next few hours, we will move further away from the garden and closer to the mountain. We will look at the trillion stars and the million light years, but we will keep our anchors. We will remember the walk across the meadow and the 19-year drive to the sun. We will keep the human scale in our hearts as we explore the divine scale of the deep. The universe is far too big for anything but peace. This is the ultimate lesson of the largest galaxy we've ever found. It is so big that conflict is impossible. It is so big that time is irrelevant. It is so big that silence is the only language that fits, and in that silence, we find our rest. We find our place. The golden anchor is waiting. The deep is calling. And we are safe in our smallness, drifting slowly into the heart of the ancient order. Now let's slowly expand outward. One level beyond our own solar system lies the Milky Way, our home galaxy. To a human, the Milky Way is unimaginably large. It contains hundreds of billions of stars, each perhaps holding its own family of planets. If our solar system were the size of a single grain of sand, the Milky Way would be the size of a large city. It takes light, the fastest thing in the universe, about 100,000 years just to cross from one side of our galaxy to the other. Scientists understand the Milky Way by observing the way its stars orbit a common center, a quiet, swirling dance of gravity that has been repeating for over 13 billion years. What we know so far suggests that we are a typical spiral galaxy, a beautiful, orderly structure of gas and dust. But even with everything we've learned, there are still things we don't fully understand about our own home. We see hints of dark matter holding the edges together, acting like an invisible scaffolding we cannot touch. Not because we're missing something urgent, but because the universe moves slowly, and we have only been watching for a heartbeat of cosmic time. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more, to an even larger scale. To truly understand the titan that is IC 1101, we must first linger for a moment in the foyer of our own home, the Milky Way. When we look up at a dark sky, we see a misty river of light flowing across the heavens. To the ancient Greeks, it was spilled milk. To others, a celestial path. Scientifically, we know it as a barred spiral galaxy, a swirling disk of dust, gas, and at least 200 billion stars. Our Sun is just one of those stars, tucked away in a quiet suburb known as the Orion Arm. We are roughly 26,000 light-years from the bright, crowded center, spinning at a comfortable pace that takes 230 million years to complete a single orbit. The last time we were in this exact spot in space, dinosaurs were only just beginning to walk the Earth. This is the rhythm of the local neighborhood. It is a slow, majestic carousel. We think of our galaxy as massive, and in human terms, it is. If you were to try and count every star in the Milky Way, 1 star per second, you would be counting for nearly 7,000 years. It is a number that exceeds the span of recorded human history. And yet, when we compare this to the largest galaxy ever found, the Milky Way begins to feel like a small, cozy village. Our home spans about 100,000 light-years. It is a vast distance, one that light, the swiftest messenger, takes a millennium of centuries to cross. But the universe is a ladder of scales, and we are currently standing on one of the bottom rungs. Scientists understand the Milky Way by observing the motion of the stars near its heart. There, stars move with a frantic, hidden energy, orbiting a central point of immense gravity. This is Sagittarius A*, a supermassive black hole. It is the anchor of our galaxy, a dark sun around which all else revolves. Yet, despite its power, it represents only a tiny fraction of the galaxy's total mass. The rest of the mass is a mystery. When we measure how fast the stars at the outer edges are moving, they seem to be moving too fast. By all the laws of visible matter, they should be flying off into the void, like water droplets spun from a wet cloth. But they stay. They are held by an invisible hand. This is the invisible scaffolding mentioned before dark matter. We cannot see it, we cannot taste it, and it passes through your body right now without leaving a trace. It is a ghost that holds the stars in place. It makes up the vast majority of our neighborhood's weight, yet it remains silent. Scientists estimate that for every gram of normal matter, the stuff that makes up trees, oceans, and your own heartbeat, there are 5 grams of this mysterious substance. We are like children looking at a magnificent building and only seeing the windows, unaware of the steel beams behind the glass. But there is no tension in this mystery. The Milky Way has been held together by this invisible support for over 13 billion years. It is not going anywhere. It is a stable, maturing structure. We see other galaxies in our local group, like the Andromeda Galaxy, which is currently drifting toward us at 250,000 miles per hour. Even at that speed, the collision won't happen for another 4 billion years. The universe is so empty that when our 2 galaxies eventually merge, the stars themselves will likely never touch. They will simply pass by each other like ghosts in a hallway, eventually settling into a new, larger arrangement. The Milky Way is a place of constant, quiet recycling. In the cold clouds of gas and dust between the stars, gravity is always at work. It pulls the dust together until it grows hot and dense, eventually igniting into a new star. When those stars die, they exhale their elements back into the void: carbon, oxygen, iron, the very ingredients that eventually formed the Earth and everything on it. We are literally made of the recycled breaths of ancient stars in this local neighborhood. It is a closed system of cosmic elegance. However, As we look further out, we realize that the Milky Way is part of a small, relatively lonely cluster called the Local Group. We have a few dozen neighbors, most of them small dwarf galaxies that look like tattered clouds. We are the big fish in a small pond. But if we were to travel toward the constellation of Virgo, or further still towards Serpens, the density of the universe begins to change. The ponds become lakes, and the lakes become oceans. When we look at the Milky Way from the outside, it is a beautiful, thin disk with graceful arms. It is a fresh galaxy, still forming stars, still vibrant with the blue light of youth in its spiral limbs. It is a place of birth and movement. But the giants we are searching for, the IC 1000, 101 South the Deep, have long since moved past this phase. They have stopped the frantic business of star birth. They have become something more singular, more monolithic. Imagine the Milky Way as a single sheet of paper. To represent the scale of the largest galaxy found, you would need to stack thousands of sheets of paper until they reached the height of a tall building. The sheer volume of space occupied by our neighbor is a drop in the bucket compared to the volumes we are about to explore. Our local neighborhood is a sanctuary of sorts, a quiet, predictable corner of the cosmos, where the light of 200 billion suns provides a sense of familiar warmth. But the horizon is calling. Beyond the edges of our dark matter halo, beyond the reach of the Andromeda Galaxy's gravity, lies the Great Attractor and the vast clusters of the Laniakea supercluster. We are moving away from the spiral life, the life of arms and disks, and toward the elliptical life, the life of pure, concentrated mass. In this transition, we leave behind the blue stars and the gas clouds. We move toward a region where the stars are older, redder, and packed together in densities that would make our night sky look like a solid wall of gold. We are moving toward the center of the Abell 2029 cluster. If the Milky Way is a suburban home, the environment around IC 1101 is a sprawling, ancient metropolis that never sleeps, yet never moves. The uncertainty of our own galaxy, the mystery of its dark matter, the exact shape of its hidden arms, serves as a gentle reminder that we are still learning the alphabet of the universe. We are like travelers who have only just stepped out of their front door and are already amazed by the size of the street. But the street leads to a city, and the city leads to a continent. As you settle deeper into your rest, let the Milky Way fade into the background. It is a sturdy home, and it will be here when you wake. Its 230 million year orbit will continue, unbothered and serene. The dark matter will continue to act as its silent guardian, but your mind is now free to drift further. We are crossing the intergalactic void, the vast empty space where light travels for millions of years without hitting a single atom. It is quiet here, between the galaxies. There is nothing to see, nothing to hear, only the soft expansion of space itself. We are moving toward a light that has been traveling for 1 billion years. It is a pale yellow glow, growing larger and larger until it fills the entire field of vision. This is the light of 1 trillion souls, the light of a galaxy that has forgotten how to be small. With that in mind, let's move outward once more, to an even larger scale. As we drift further from the familiar spiral arms of our Milky Way, we enter the great intergalactic desert. This is a place where distance takes on a physical weight. Between our home and the destination we seek, There are stretches of nothing so vast that entire civilizations could rise, reach the stars, and fade into dust without ever crossing the gap. In this space, the atoms are so few that you could travel for 1,000 years and never encounter a single grain of matter. It is a vacuum of such purity that it makes the air in your room feel like a dense, heavy liquid. Here, in the profound stillness of the local neighborhood's edge, we begin to realize that the universe is not made of objects, but of the space that holds them. To understand the journey we are taking, we must look back at our own cluster, the local group. It is a small, intimate collection of galaxies. The Milky Way and Andromeda are the two anchors, spinning around each other in a slow, multi-billion-year embrace. Around us are the stragglers, the Magellanic Clouds, the Triangulum Galaxy, and dozens of dwarf galaxies that look like tattered scraps of silk. This is our porch. It is a cozy corner of the cosmos. But as we move outward, the neighborhood begins to change. The gaps between the stars are replaced by the gaps between the galaxies. We are leaving the era of the individual sun and entering the era of the collective glow. Scientists understand this transition by measuring the redshift of the light. As we move away from our local group, the expansion of the space itself stretches the light waves, pulling them toward the red end of the spectrum. It is a subtle, inevitable change. It tells us that the universe is breathing outward, pushing the galaxies apart like seeds in a growing fruit. This expansion is not a wind. There is no force pushing against us. It is simply the creation of more wear. More space is coming into existence every second between us and the giant in the distance. This is a gentle mystery. We don't fully understand why the space is growing, but we can feel the peace of its expansion. It provides a buffer of silence that protects the fragile structures of life from the immense energies of the deep. What makes this strange is not what we see, but what we don't. As we cross the intergalactic void, we are moving through the halo of our galaxy's dark matter. Astronomers didn't expect to find that the nothing between galaxies is actually filled with an invisible scaffolding. It is a web of gravity that we cannot touch or see, yet it is the only thing that keeps the galaxies from flying apart into total isolation. It is a quiet, steady support. It is like the foundation of a house that you never see but always trust. In the local neighborhood, this dark matter is the silent guardian of the order we take for granted. Imagine the time it takes for a message to travel across this neighborhood. If you were to send a beam of light from one side of the local group to the other, it would take nearly 10 million years to arrive. Any news we receive from our neighbors is ancient by the time it reaches our eyes. We are looking at a history book written in the language of photons. There is a deep intellectual comfort in this delay. It means that nothing in the universe happens suddenly. Everything has a long lead time. The light of the giant galaxy IC 1101, which we are now approaching, has been traveling toward us since before the first mountains on Earth were raised toward the sky. It is a light that has seen the birth of every creature that ever walked the ground beneath you. As we move further out, the individual stars of the Milky Way merge into a single, faint smudge of light behind us. Our sun is no longer visible. Our planets are gone. The entire history of humanity is contained within a speck of light that is slowly vanishing into the distance. This challenges how we think about our own importance, but it does not diminish us. Instead, it expands us. We are the consciousness that has traveled this far. We are the part of the universe that is looking back at the porch we just left. There is no urgency to return. The local neighborhood is safe. It is held in the same laws of physics that govern the giant we are about to meet. Scientists observe these distant scales by using gravitational lenses, places where the mass of a cluster is so great that it bends the light from even more distant objects, like a cosmic magnifying glass. It is as if the universe is helping us to see it. It is providing the tools for its own discovery. This suggests a sense of cosmic continuity, a feeling that the universe is not just a random collection of things, but a coherent system that wants to be understood. As we move outward, we are not moving into chaos. We are moving into a more complex form of order. Everything is in its place. The local group is a memory. The intergalactic void is our current path, and the giant is the destination. We are moving toward a light that has forgotten how to be small, and as we do, we find that we, too, are beginning to forget the weight of the ground. We are becoming part of the drift. We are becoming part of the scale. The steady, unceasing flow of time and space is the only thing that matters now. The numbers are fading. The distances are merging. There is only the light, the yellow glow of a trillion suns, waiting to tell us the rest of the story. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth. And mehr. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs. light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light-years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light-years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. When we think about the strangeness of space, we often imagine it in human terms. We think of distances we can walk, or a drive across the country. If you were to walk around the Earth at a steady pace, it would take you about a year of constant movement. That feels like a long time. It is a scale we can almost grasp: the soreness in our legs, the changing of the seasons. But space does not care for our walking speeds. If we were to take a standard passenger jet and try to fly to the moon, it would take us about 18 days. To reach the sun, that same plane would have to fly for 19 years. You would board as a young adult and disembark as someone looking toward middle age, all while traveling through a vacuum that feels like nothing yet contains everything. Astronomers often find things that challenge these human measures. We look for patterns, for things that make sense, like a house or a car or a familiar street. But the further we look, the more we find objects that defy our expectations of how matter should behave. This comparison isn't perfect, but it gives us a calm place to begin. To truly appreciate the strangeness of the deep cosmos, we must first acknowledge the limits of our own senses. Our eyes evolved to spot fruit in trees and movement in the tall grass. Our hands are designed to grip tools and feel the texture of the earth. We are built for a world of medium sizes, medium speeds, and medium temperatures. When we step outside this narrow corridor of experience, the universe begins to look less like a home and more like a vast, beautiful, and utterly indifferent ocean of mystery. Consider, for a moment, the concept of a long walk. For most of us, walking for 4 or 5 hours is a significant undertaking. It leaves us tired, our muscles humming with a dull ache, our minds focused on the destination. If you were to walk around the entire circumference of the Earth, it would take you nearly a year of constant, rhythmic movement, never stopping for sleep or food. This is the largest thing most of us will ever interact with the planet itself. And yet, on the scale of the things we have discovered in the dark, the Earth is little more than a speck of dust caught in a sunbeam. It is a tiny, fragile marble in a room the size of a cathedral. When we talk about the strangest objects in space, we are often talking about things that violate our sense of density. On Earth, we know what a rock feels like. It is heavy, solid, and dependable. We know what water feels like and how air feels when it brushes against our skin. But in the deep reaches of the Milky Way, we have found objects like neutron stars, remnants of giant suns that have collapsed under their own weight. To understand the strangeness here, imagine taking a mountain, something like Mount Everest, and crushing it down until it is the size of a single sugar cube. That is the density of a neutron star. A single teaspoon of its material would weigh billions of tons. It is matter, but not matter as we understand it. And it is matter pushed to its absolute limit, a physical manifestation of gravity's overwhelming power. Even our sense of time is a human-scale illusion. We measure our lives in decades, our history in centuries, and our civilizations in millennia. We think of the pyramids as ancient, but in the timeline of the universe, the pyramids were built just a fraction of a second ago. The stars we see at night are not static lights. They are roaring furnaces that burn for billions of years. Some of the strangest things we have discovered are zombie stars, white dwarfs that have finished their primary life cycle and are now slowly, patiently cooling down over trillions of years. They will continue to glow long after the last human has been forgotten and long after the Earth itself has been reclaimed by the Sun. They exist on a scale of patience that we cannot truly comprehend, a slow-motion fading that mirrors the cooling of a hearth on a winter night. As we look further out, we encounter the mystery of voids. In our daily lives, we are surrounded by things. Rooms are filled with furniture, streets are filled with cars, and the atmosphere is filled with nitrogen and oxygen. We have a natural aversion to total emptiness. Yet, in the deep cosmos, we have found regions of space where there is simply nothing. These are the great voids, vast bubbles in the cosmic web where there are no stars, no planets, and no light for hundreds of millions of light years. To a human perspective, this is unsettling. We look for the patterns, the houses, and the familiar streets, but in the void, there is only the silence of the vacuum. It challenges our belief that the universe is full. Instead, it suggests that the things we see, the glowing nebulae and the bright galaxies, are merely thin decorations on a much larger, emptier canvas. We also find strangeness in the way light behaves. We think of light as instantaneous. When you flip a switch, the room is bright, but in space, light is a messenger that takes time to arrive. When you look at the moon, you see it as it was 1 second ago. When you look at the sun, you see it as it was 8 minutes ago. If the sun were to suddenly vanish, we would continue to see its light and feel its warmth for a full 8 minutes, unaware that our anchor had disappeared. This light-time delay means that the further we look into space, the further we are looking back in time. We are cosmic historians, looking at the ghosts of stars that may have died before our ancestors even walked upright. This is the ultimate challenge to our human perspective. The realization that the now we experience is a local phenomenon, and that the universe is a vast collection of different thens, all overlapping in the night sky. To understand the scale of these discoveries, we must also consider the strange nature of Goldilocks planets, of worlds that sit in the comfortable zone where liquid water can exist. We look for these worlds because they remind us of home. We look for blue skies and rocky shores. But many of the planets we find are alien in ways that are difficult to visualize. We have found planets where it rains molten glass, driven by winds that move at 7 times the speed of sound. We have found planets that are tidally locked, meaning one side is a permanent, scorched desert, while the other is a permanent, frozen wasteland. These worlds are not broken, they are simply operating under different conditions, following the same laws of physics that govern our own backyards, but pushed to different extremes. Even the way we perceive up and down is a human-scale convenience. On Earth, gravity pulls us toward the center of the planet, giving us a sense of orientation. In the weightlessness of orbit, up loses its meaning. But even further out, in the presence of a black hole, the very geometry of space becomes warped. Imagine a trampoline with a heavy bowling ball in the center. The fabric stretches and curves. Now, imagine an object so heavy and so small that it rips a hole in that fabric entirely. This is a singularity. Near a black hole, time itself begins to slow down. If you were to watch someone fall toward the event horizon, you would see them slow down and eventually appear to freeze in time, while for them, the universe would appear to speed up into a blur of future history. This is the strangest discovery of all, that space and time are not a fixed stage, but a flexible, living thing that can be stretched, twisted, and torn. As we drift further into the night, we must leave behind our need for human comparisons. We must accept that the universe is under no obligation to be sensible to us. It is a place of extremes, of absolute zero, and of trillion-degree explosions, of total emptiness, and of infinite density. But as we let go of our human scale, we find a different kind of comfort. There is a relief in realizing that the universe is so much larger than our problems, our politics, and our fleeting anxieties. We are small, yes, but we are the part of the universe that has developed the ability to look back at itself and wonder. We are the witnesses to the strangest things ever discovered. Think of a single grain of sand held at arm's length against the night sky. That tiny patch of darkness behind that grain of sand contains thousands of galaxies, each with hundreds of billions of stars. This was the discovery made by the Hubble Deep Field, and it remains one of the most humbling realizations in human history. It reminds us that our familiar streets are just one tiny corner of an infinite neighborhood. The strangeness we find out there is not a sign of chaos, but a sign of the sheer diversity of what is possible when you have 14 billion years and an infinite amount of space to work with. As you settle deeper into your rest, allow these scales to fold in on themselves. The vastness of the Botez void is balanced by the intricate dance of atoms in your own body. The immense heat of a diamond planet is countered by the absolute cold of the cosmic microwave background radiation that permeates every inch of the room around you. You are part of this grand architecture. You are made of the same stardust that forms the rings of Saturn and the spiral arms of Andromeda. The same gravity that holds the galaxies together is the same gravity that holds you safely in your bed tonight. The universe is strange, yes, but it is also consistent. It follows rules that we are slowly, patiently beginning to decode. And while those rules lead to phenomena that defy our everyday logic, they also create a universe of profound beauty and order. We don't need to fear the great nothing or the singularity, because they are simply parts of a whole that we are privileged to observe. For now, let the numbers fade. Let the light years and the billions of tons drift away. You are back on a human scale now, in a quiet room, on a small blue world, protected by an atmosphere that feels like a blanket. The strangest things we've discovered in space are not just out there, they are clues to the nature of reality itself. And as we continue to look, we find that the more we learn, the more we realize how much is left to see. But that is a task for tomorrow. For tonight, the stars will continue their long, slow burn without our supervision. The rogue planets will drift, the alcohol clouds will swirl, and the diamond worlds will shine in the dark. The universe is moving gently forward, and you are moving with it, safe and still, as we prepare to move outward once more to an even larger scale. To truly anchor ourselves, let's consider the scale of a single human life against the backdrop of a cosmic day. If the entire history of the universe, all 13.8 billion years, were compressed into a single calendar year, the average human life would last for about 0.2 seconds. We are, in the most literal sense, a blink of an eye. Yet, in that blink, we have learned to measure the weight of stars and the composition of distant atmospheres. This is the paradox of our existence. We are physically insignificant, yet intellectually vast. We are small enough to be cradled by the Earth's gravity, but our curiosity is large enough to span the light years. When we look at the objects in our own homes, a wooden table, a glass of water, a metal key, we see solid, dependable things. But as a scientist would tell you, these objects are mostly empty space. If you were to remove all the empty space from the atoms that make up every human being on Earth, the entire population of our planet would fit inside the volume of a single sugar cube. It would be an incredibly heavy cube, of course, but it illustrates how much nothing there is, even in the things we consider something. Space is not just the distance between the stars. It is the distance between the very particles that make up your own body. You are, in a sense, a small collection of concentrated space, walking through a larger field of space. Astronomers often find things that challenge these human measures. We look for patterns, for things that make sense, like a house or a car or a familiar street. But the further we look, the more we find objects that defy our expectations of how matter should behave. Take, for example, the sheer scale of the sun. To us, the sun is a warm circle in the sky, essential but familiar. If the sun were the size of a typical front door, the Earth would be the size of a nickel. You could fit 1.3 million Earths inside the sun, and yet our sun is considered a yellow dwarf, a relatively modest star. There are stars like Uy Scuti, so large that if it were placed at the center of our solar system, its surface would extend past the orbit of Jupiter, swallowing everything we've ever known in a sea of plasma. Tonight, you can set that conscience aside. You don't need to be the thinker or the observer right now. You can simply be a part of the matter. You can be the carbon, the nitrogen, and the oxygen resting in the gravity of the Earth. You are moving gently forward with the planet, with the sun, and with the galaxy. The motion is so smooth you can't even feel it. It is the ultimate lullaby, the silent, rhythmic movement of the entire universe toward tomorrow. But here, on the human scale, the strangest thing of all is the peace you can find in the middle of it all. It is the ability to look out at the infinite and still find the comfort to sleep. It is the realization that the universe is vast, but it is also home, safe and still, as we prepare to move outward once more to an even larger scale. This delay is the first layer of the deep drift. It is a reminder that the universe has a built-in latency. We are always looking at the past. The further we look, the deeper into history we descend. This challenges how we think about the present moment. Is there even such a thing as now for the entire universe? Plus, or is now just a local experience, limited by the speed at which information can travel? Scientists have spent centuries debating this, and yet the mystery remains as calm and quiet as the stars themselves. Consider the Voyager spacecraft, the furthest human-made object. It has been traveling for decades, moving faster than any bullet ever fired. Yet, if we were to send a light signal to Voyager today, it would reach the craft in less than a day. Light covers in hours what it takes our best technology half a century to achieve. This is the scale of the marathon light is running. It is a constant, tireless sprint across a stadium that has no walls. But even with everything we've learned, there are still things we don't fully understand. We don't know why light moves at this specific speed. Why 300,000 kilometers per second? Why not more? Why not less? It is one of the fundamental constants of nature, a number woven into the fabric of space-time itself. It doesn't need to be explained or justified. It simply is. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. As we settle into this scale, let your mind rest on the idea of the light second. It is a distance of 300,000 kilometers, nearly 10 times the circumference of the Earth. It is a massive distance, yet it is only 1/62nd of a light minute, and a light minute is but a tiny fraction of a light year. We are building a tower of scale, and the light second is just the foundation. Imagine you are a traveler made of light. You leave the Earth behind. In 1 second, you have passed the moon. In 2 minutes, you are passing the inner planets. In 8 minutes, you reach the Sunday. 12. You are moving so fast that the planets appear like stationary marbles in a vast, dark room. But as you look ahead, you realize the room is much larger than you thought. The next nearest object is not minutes away. It is not hours away. It is years away. This is where the true scale of the light year begins to reveal itself. To cover the distance of 1 light year, you would have to maintain this 300,000 kilometer per second pace for 31,536,000 seconds. Every second, another 300,000 kilometers. Every hour, another billion kilometers. Day after day, month after month, for an entire year. By the end of that journey, you would have traveled nearly 9.5 trillion kilometers. That is 1 light year. If we tried to use kilometers to describe the distance to the nearest star, we would be talking about 40 trillion kilometers. The numbers become a noise, a static that our brains cannot process. But 4.2 light years is something we can hold. It is a duration. It is the length of a high school education. It is the time it takes for a toddler to become a student. It gives the distance a human heartbeat. As you drift closer to sleep, imagine these beams of light crossing the void. They are silent. They do not carry heat across the vacuum. They are just pure information, pure energy, traveling through a cold, dark expanse that is mostly empty. The universe is not a crowded place. It is a series of very small lights, separated by very large silences. The light year is the measurement of that silence. We are moving outward now, leaving the realm of the light second and the light minute. We are entering the space where the light year becomes the only sensible way to speak. It is a transition that feels inevitable, like the slow turning of the tide. You don't need to do anything. You don't need to solve any equations. Just let the speed of light become the background rhythm of your thoughts. The universe moves slowly over immense spans of time, even when it is moving at the speed of light. And for now, that uncertainty, that vastness, is simply part of the picture. It is a safe place to be. You are here, in your bed, while the light is out there, doing the work of bridging the distances for you. With that in mind, let's move outward once more, to an even larger scale, beyond the speed of light, beyond the inner solar system, and toward the gaps that define our place in the galaxy. We are now entering the territory where the human-scale anchor no longer just slips. It vanishes entirely. To understand the transition from the speed of light to the distance of a light year, we have to look at the sheer, overwhelming volume of the vacuum. Imagine for a moment that we could drain the universe of all its stars, all its planets, and all its dust. What remains is the canvas upon which light performs its marathon. This canvas is so vast that even at 300,000 kilometers per second, light is not a flash. It is a slow, steady pulse, a lonely traveler crossing a desert that has no markers. As we drift further from the sun, we begin to encounter the true nothingness that defines the cosmos. In our daily lives, empty usually means a room without furniture or a glass without water. But in the space between the stars, empty is a profound, almost mathematical purity. There are regions of space where you could travel for a light year, 9.5 trillion kilometers, and encounter fewer atoms than you would find in a single grain of sand. This is the low-density reality that light must navigate. When we say that a star is 4 light-years away, we aren't just saying it's far. We are saying there is a 4-year-long gap of absolute, freezing silence between us and that distant fire. Scientists understand this by calculating the look-back time. This is a concept that acts as a verbal dissolve between the present and the past. Because light has a fixed speed, every distance in the universe is also a measurement of history. If you look at an object that is 1 light year away, you are seeing it exactly as it appeared 365 days ago. You are not looking across space so much as you are looking through time. This challenges how we think about the reality of the now. In the deep drift of the galaxy, there is no simultaneous moment. Each star exists in its own bubble of time, sending out messages that will not be received for years, decades, or centuries. Consider the sheer scale of a single light year once more. To visualize 9.5 trillion kilometers, imagine the distance from the Earth to the Sun, that 8-minute journey we discussed earlier. Now, take that distance and stack it end to end, 63,000 times. That is 1 light year. It is a distance so long that if you were to represent the Earth-Sun distance as 1 inch, a single light year would still be over a mile long. And remember, the nearest star is over 4 of those miles away. This is the scale expansion that begins to blow the human mind. We aren't just moving away from home, we are moving into a geography that refuses to be tamed by our standard maps. What makes this strange is not what we see, but what we don't understand about the nature of the vacuum itself. Astronomers didn't expect to find that space is expanding, a discovery that adds a layer of quiet complexity to our journey. As light travels its 9.5 trillion kilometers every year, the space it is traveling through is itself stretching very slightly every second. It's as if the marathon track is growing longer while the runner is mid-stride. This doesn't affect our local neighborhood much, but over the immense periods of time that light spends in transit, it changes the very color and energy of the light itself. It is a slow, rhythmic stretching of reality that happens without hurry and without end. As you listen, let the rhythm of these numbers settle into your breathing. Ow, 300,000 kilometers per second. 18 million kilometers per minute. 1 billion kilometers per hour. These are not numbers to be feared or solved. They are simply the heartbeat of the vacuum. They represent the tireless work of the universe, moving energy from one place to another across the dark. You are safe in the knowledge that this process is constant. The speed of light does not falter. It does not tire. It is the one thing in the universe that remains exactly the same, no matter where you are or how fast you are moving. And for now, that uncertainty about why the universe is so large and why we are separated by such vast gulfs of time is simply part of the picture. It doesn't need to be resolved tonight. We can accept the silence of the light years. We can accept that the stars we see tonight are ghosts of their past selves, and that our own light is currently traveling outward, a faint signal crossing the void to reach eyes that won't exist for another million years. This is the cosmic continuity, the realization that we are all part of a single, slow-moving story. Imagine you are a photon that has just finished its first year of travel. You have covered 1 light year. You look back, and the sun is no longer a blinding disk. It has shrunk to a bright, steady point of light, one star among many. You look forward, and the destination still looks impossibly far away. There is no wind in space, no sound, and no resistance. You are simply falling through the dark at the maximum possible speed, a tiny spark of information in a cathedral of shadow. This is the essence of the scale loop. We expand our view, we realize the vastness, we accept the mystery, and then we move outward once more. To understand that, we need to step back and look at the human scale perspective one last time before it disappears completely. On Earth, we think of a year as a long time. It is a cycle of seasons, a series of memories. But to the universe, a year is just the time it takes for light to cross a tiny fraction of a galaxy. When we combine the two, the human year and the cosmic speed, we get the light year. It is our way of speaking the universe's language using our own alphabet. It is a gentle humility, acknowledging that while we may be small, we have found a way to measure the infinite. As we conclude this first scale loop, let the image of the light marathon carry you toward a deeper state of relaxation. The light is moving, but you are still. The universe is vast, but you are warm and safe. The distances are mind-blowing, but they are also orderly and predictable. There is a peace in the precision of the speed of light. It is the ultimate clock, ticking away the seconds across the trillions of kilometers. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We have reached the first marker on our journey. We have looked at the speed, we have looked at the distance, and we have accepted the delay. We are now ready to leave the inner solar system behind for good and look at the objects that wait for us in the deep, quiet dark of the interstellar gaps. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward, one level beyond the speed of light, lies our own neighborhood, the solar system. To truly grasp the weight of a light year, we must first look at the smaller, more intimate delays that happen right here in our own backyard. We often think of our solar system as a single cohesive unit, a family of planets huddling around a central fire. But even within this family, the distances are so great that light, the fastest messenger in existence, begins to show the first signs of its struggle against the void. This is where we first encounter the lag of reality, a gentle reminder that nothing in the universe happens in a true, synchronized now. What we know so far suggests that the Moon is about 384,000 kilometers away. To our human-scale perspective, this is a massive distance, a journey that took the Apollo astronauts 3 days of intense travel to complete. But for light, this gap is merely a brief pause. When you look up at the Moon tonight, you are seeing it as it was 1.3 seconds ago. It takes that long for the sunlight bouncing off the lunar surface to reach your eyes. This is the lunar delay. It is a small, almost imperceptible gap, but it is the first crack in the illusion of an instantaneous universe. If a large boulder were to roll across the lunar plains, or if a meteorite were to strike the surface, you would remain unaware of it for over a second. You are always watching a slightly delayed broadcast of our nearest neighbor. As we move past the Moon, the seconds begin to turn into minutes. The Sun, the very engine of our lives, sits much further away, about 150 million kilometers. This is the distance astronomers call an astronomical unit, or 1 AU. It is the gold standard for measuring our local neighborhood. Yet, even light needs time to cross this threshold. It takes 8 minutes and 20 seconds for a photon to travel from the surface of the Sun to the Earth. If the Sun were to suddenly go out, we wouldn't know it for 8 minutes. We would continue to live in its warmth and light, unaware that its source was already gone. Children would keep playing in the park, solar panels would continue to generate power, and the world would remain bright, all while the Sun itself was already dark. We would continue to orbit a ghost of a star for those final 8 minutes. This comparison isn't perfect, but it gives us a calm place to begin. It shows us that even the most fundamental things in our lives, the very light of day, are subject to the patient laws of cosmic distance. Scientists understand these delays by observing the movement of the planets. When we send rovers to Mars, for instance, we cannot drive them in real time with a joystick. Depending on where Mars and Earth are in their orbits, the light delay can be anywhere from 3 to 22 minutes. If a rover is heading toward a cliff, the signal telling it to stop takes minutes to arrive, and the confirmation that it has stopped takes another few minutes to return. We are forced to communicate with the solar system through a veil of time. We are always talking to the past version of the planets, and they are always responding to a past version of us. But even with everything we've learned, there are still things we don't fully understand about how these distances affect our perception. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. To understand the scale, imagine you are standing in a vast, dark forest. You have a friend standing a few hundred yards away with a bell. When they ring the bell, you hear the sound a moment later because sound travels slowly. In the solar system, light is like that bell. It is incredibly fast, but the forest is so big that the sound of the light still takes time to reach your ears. As we drift further out, to the gas giants like Jupiter and Saturn, the minutes turn into hours. When we look at Jupiter, we are seeing it as it was 40 minutes ago. When we look at Saturn, the light has been traveling for over an hour. If you were to watch the beautiful rings of Saturn through a telescope, you are seeing them not as they are in this moment, but as they were while you were perhaps finishing your dinner or starting this very script. The universe is a series of nested time capsules, each one holding a slightly older version of reality. This brings us to a quiet realization. We are never truly in the present when we look at the sky. We are observers of history. The light minutes that separate us from the planets are the first steps toward the light years that separate us from the stars. It is a gradual expansion of the now until it becomes so thin that it disappears entirely. In our daily lives, we measure time in seconds, minutes, and hours. But in the solar system, we begin to see that time and distance are the same thing. 1 AU is not just 150 million kilometers, it is also 8 light minutes. The distance is the time. Astronomers didn't expect the solar system to feel so empty, yet the gaps between the planets are far larger than the planets themselves. If you were to shrink the sun to the size of a grapefruit, the Earth would be a tiny grain of sand about 50 feet away. Jupiter would be a cherry about 2 blocks away, and the nearest star, that grapefruit, would be thousands of miles away. This is why we need the light year. Kilometers are too small to bridge the gaps between the fruits in our cosmic orchard. When we think about distance, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. It is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, a beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit, and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the sun safely, through a filter or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the sun, traveling through the cold dark for 8 minutes, and finally reaching the earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human scale perspective, we are also speaking of human scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts, the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car, but light is the ultimate speed. It is the speed limit of reality. Nothing can go faster, and yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. The roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. While you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human-scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were 1 billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3 second gap that you could never bridge. And so the universe continues, expanding, cooling, changing slowly, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. The stars of IC 1101 will continue to burn for trillions of years, long after the memory of this night has dissolved into the quiet hum of the background radiation. There is no final answer to find in the dark. There is only the drift, the slow, rhythmic expansion of space between the galaxies, the gradual cooling of the great giants, the silent movement of the cosmic web. And, somewhere within all of this, we can begin again by starting with something familiar, by returning to the breath, to the quiet, to the slow, steady rhythm of a universe that has all the time it needs. The light is still traveling, the void is still waiting, and everything is exactly as it should be, moving gently forward, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. The stars of IC 1101 will continue to burn for trillions of years, long after the memory of this night has dissolved into the quiet hum of the background radiation. There is no ending to a story of this scale. A galaxy that spans 6 million light-years does not simply stop. It persists. It endures. It exists as a testament to the fact that the universe has no finish line. As you lie here, the light from a trillion suns is still moving through the room. It is invisible to the eyes now, but it is part of the texture of the space you inhabit. The atoms that were once part of a distant nebula are now the very atoms that make up the pillow beneath your head. The continuity is complete. The circle has closed. We return to the familiar ground, but we return with the quiet weight of the cosmos within us. Imagine the slow expansion of the universe as a long, deep exhale. It has been exhaling for 13 billion years, and it is in no rush to breathe back in. This is the ultimate rhythm of the infinite ending. It is a state of perpetual moving away, a gradual widening of the gaps between the stars. In this widening, there is more room for silence. There is more room for the mind to let go of its anchors. The giant galaxy IC 1101 is drifting just as you are drifting. It is part of a cluster that is drifting within a supercluster, which is drifting along the filaments of the cosmic web. Everything is in motion, yet everything feels perfectly still. At this scale, the concept of time becomes a soft, blurred edge. We no longer measure it in hours or days. We measure it in the cooling of red giants. We measure it in the slow, inevitable stretching of light waves as they travel across the void. This is the time of the infinite. It is a time that does not demand anything from you. It does not ask you to be productive, or to understand, or to remember. It simply invites you to exist within it. You are a passenger on a journey that has no destination. And because there is no destination, there is no reason to hurry. The universe is a master of the slow transition. It does not switch from day to night with a snap. It uses the long, lingering colors of twilight. It does not move from the Milky Way to IC 1101 without the vast, meditative space of the intergalactic void. And tonight, it does not move from wakefulness to sleep with a jolt. It uses the scale of the trillion stars to gently pull you under. It uses the history of the Abell cluster to weigh down your thoughts until they are as heavy and as calm as the dark matter that holds the galaxies together. In the heart of the largest galaxy we've ever found, there is a black hole that is 40 billion times the mass of our Sun. It is a silent, heavy center. It is the ultimate anchor. Imagine your mind settling into that same kind of heavy, silent center. A place where gravity is so strong that even a stray thought cannot escape its pull. A place of total, absolute stillness. From this center, the rest of the universe looks like a distant, glowing fog. The trillion stars are just a faint shimmer on the horizon. The cosmic web is just a memory of a pattern. You are at the very core of the giant, where the light is brightest and the silence is deepest. Over immense periods of time, the universe will continue to grow. The voids will expand until the galaxies are so far apart that their light can no longer reach one another. But even in that distant, lonely future, the laws of physics will remain. The gravity will still pull. The atoms will still vibrate. The continuity will not be broken. The infinite ending is not a disappearance. It is a transformation into a more perfect silence. It is the final, most beautiful version of the drift. You can let go of the galaxy now. You can let go of the red giants and the golden orbs. They are safe in their orbits. They do not need your attention to stay held in the dark. IC 1101 will be there tomorrow, and 1 billion years from tomorrow, still glowing with its amber history. It is a permanent fixture in the architecture of the deep. You can leave the watch to the telescopes and the equations. Your task is simpler. Your task is to participate in the silence. The light is still traveling. The photons that began their journey when the Earth was young are arriving now, and the photons leaving the giant today will arrive when the Earth is long gone. This is the overlap of the infinite. We are all living in the light of things that happened before us, and we are all contributing to the light of things that will happen after us. It is a seamless, beautiful tapestry of cause and effect. As the rhythm of your breath slows, let it match the rhythm of the expanding space. Breathe in the scale of the cluster. Breathe out the urgency of the moment. There is plenty of time. There is more time than there are atoms in the universe. There is more space than there are thoughts in a human life. You are resting in a reservoir of infinity, and somewhere within all of this, we can begin again. The stars of the golden giant are not dying. They are merely changing their frequency. They are moving from the visible into the invisible, from the heat into the cool of then. This is the way of all things. The infinite ending is a process of softening, of becoming less solid and more like the space that surrounds us. We are dissolving into the background radiation, becoming part of the hum that started the whole story. There is no goodbye in the cosmos. There is only a until the next light. The universe is a closed loop of energy and matter, and nothing is ever truly lost. The part of you that wonders about the stars is the same part of the stars that once wondered about the dark. We are the universe waking up to itself, and now it is time for that consciousness to rest. In this infinite ending, the boundaries between the largest galaxy ever found and the smallest thought in your mind have finally dissolved. We have traveled across 6 million light years of golden starlight, through the invisible threads of the cosmic web, and back to the quiet rhythm of your breath. The journey does not end with a destination. It ends with a return to the realization that you have always been a part of the architecture. Imagine the universe as a grand, silent clock that never needs to be wound. It does not measure hours, but the slow cooling of white dwarfs and the steady expansion of the space between clusters. In this clockwork, IC 1101 is a masterpiece of longevity. It sits at the center of Abell 2029, its trillion stars glowing like embers in a hearth that will stay warm for 100 trillion years. We often worry about the end of things, the end of a day, the end of a year, the end of a life. But the universe doesn't share this concern. To the cosmos, an ending is simply a rearrangement. A star that exhausts its fuel becomes a white dwarf, which becomes a black dwarf, which eventually returns its heavy elements to the void to wait for the next chapter. Nothing is discarded. Everything is archived in the deep memory of the dark. As you drift deeper into the stillness, consider the light of the giant once more. It is a light that has forgotten the frantic urgency of youth. It is a light that has learned the value of persistence. When we look at the amber glow of IC 1101, we are looking at the ultimate victory of stability over chaos. The galaxy has consumed everything in its path, not out of hunger, but out of a gravitational inevitability. It has reached a state of perfect, monolithic peace. It is the destination of all the matter in its neighborhood, a final resting place for the wandering gas and the lonely stars of the cluster. In this way, the largest galaxy is a metaphor for the sleep you are now entering, a total, unified concentration of peace that draws in all the stray thoughts of the day and settles them into a single golden glow. Scientists understand the fate of the universe by observing the heat death, a concept that sounds dramatic, but is actually the ultimate expression of quietude. It is the moment, trillions of years from now, when the universe reaches a uniform temperature. There will be no more hot suns or cold voids. There will only be a perfect, lukewarm balance. The stars of IC 1101 will be among the last to fade, their low-energy red dwarfs outlasting every blue giant in the sky. This is not a tragedy. It is the universe finally finding its most comfortable state. It is the ultimate exhale. It is the moment when the cosmic continuity reaches its conclusion and the universe enters a sleep that has no dreams. But even that distant horizon is just another transition. In the closed loop of energy, every ending contains the seeds of a beginning. Perhaps the dark energy that pushes the galaxies apart today will one day reach a limit, or perhaps the fluctuations in the vacuum will spark a new inflation. We don't need to know the physics of the next universe to feel the security of this one. We can accept the uncertainty as a form of infinite potential. The void is not a lack of something. It is a presence of everything that hasn't happened yet. It is the silence between the notes of a song that makes the music possible. You are moving now into the most abstract part of the drift. The numbers, the trillion stars, the billion light years, the 40 billion solar mass black hole have become like the ticking of a clock that you no longer hear. They are the background noise of existence. Your mind is expanding to match the volume of the Abell cluster. You are no longer a person in a room. You are a consciousness in a void. You are the space between the filaments. You are the dark matter holding the edges together. You are the ancient light that has been traveling for an eternity just to find a place to rest. The part of you that wonders is now quiet. The part of you that remembers is now still. The universe is taking over the task of thinking for you. It is calculating the orbits of the stars in IC 1101. It is managing the expansion of the voids. It is weaving the cosmic web. You can let go of the burden of awareness. You can trust that the universe will keep the stars in their places while you are away. It has been doing so for 13 billion years. It does not need your help tonight. The order is ancient, and the order is absolute. The light is still traveling, the void is still waiting, the giant is still glowing, moving gently forward, quietly, endlessly. You can begin again now, by starting with something familiar, by returning to the breath, to the quiet, to the slow, steady rhythm of a universe that has all the time it needs. You are drifting now, beyond the numbers, beyond the stars, into the heart of the golden orb, into the center of the silence. The universe is safe, and you are safe within it. Until the next light, good night.